Hello and welcome back to another A-level and IB chemistry tutorial with me, Miss T. Today's tutorial is on empirical formula, starting with some definitions, worked examples, and then of course some practice questions for you to try. So we're very familiar with molecular formulae, which is just the number of atoms of an element in a compound. But when we get to empirical formula, that's the simplest whole number ratio of atoms of an element in a compound. So we would find the highest common factor and then simplify. So for H2O2, we can divide both by 2. C2H4, again, divide by 2 to give CH2 and C2H6, or again, divide by 2 to give CH3. When it comes to calculating empirical formulae from data, we can do that from masses or from percentages. We can treat them in exactly the same way. So if we start here with trying to find the molecular formula of magnesium oxide, given the mass of magnesium and the mass of oxygen that it reacted with. We know when in doubt, we're going to find the moles. So moles equals mass over the relative atomic mass. And so for magnesium, we get 0.00123, and in oxygen, we get 0.00125. Now, in order to get those moles into whole number ratios, we identify which of those two moles is the smallest. In this case, it's the one I've put in bold here. And we divide both of the moles by the smallest number. So for magnesium, that will give us 1. And for oxygen, that will give us 1.02. Now, 1.02 is very, very, very close to 1. So we'll just call it 1, which gives us the empirical formula of MgO. 1 atom of magnesium for every 1 atom of oxygen. That's the simplest whole number ratio. Our next worked example, so this time we're dealing with percentages, but we deal with percentages in exactly the same way as we do with masses. So still percentage this time divided by relative atomic mass, which gives us 1.30 for iron and 1.725 for oxygen. 1.30 is the smallest of the two, so we'll divide both values by 1.30, and that gives us a ratio of 1 to 1.33. Now, 1.33 is not close enough to 1 to round down, so we need to multiply that by 3 in order to get to the whole number. And if you multiply that by 3, you have to multiply the other one by 3 as well, which gives you a ratio of 3 to 4. So our empirical formula is Fe3O4. In general, if you end up with a number of moles that's around 0.5, then you know you're going to have to multiply it by 2 to get to a whole number. If it's 0.25, you'd multiply it by 4 to get to a whole number. And if, like in this case, is 0.33 or 0.67, then multiply by 3 to get to the whole number ratio. Final example, and this time we're going one step further to find the molecular formula. So we'll follow the same steps as before, mass divided by relative atomic mass to give the moles, divide each by the smallest one, which in this case is 2.27, and then we end up with a ratio of 2 to 4 to 1. So our empirical formula is C2H4O. The 1 is silent. Okay, now to get from empirical formula to molecular formula, we need to use the molecular mass or the MR from the question. So first, we'll find the MR of the empirical formula, so C2H4O, which gives us an MR of 44. The molecular mass that they gave us in the question is 132. So if we do 132 divided by 44, we see that gives us a value of 3. So our molecular formula must be 3 times as much as the empirical formula. So if the empirical formula is C2H4O, the molecular formula must be C6H12O3. So multiplying each of those values by 3, scaling up to get to the molecular formula. So now it's your turn to do some practice. All of the relative atomic mass values that you need are over to the right. Pause the video now and then press play when you're ready with the answer. So our first example, nice and straightforward. Calculate the moles, divide by the smallest number of moles, which is 0.2275, which gives us a whole number ratio of 1 to 2. So our empirical formula is CO2. For our next example, again following the same steps, this time when we divide by the smallest number of moles, we get 1 to 1 to 1.5. So in order to get to the whole number ratio, remember if we're ending with a 0.5, we just multiply everything by 2. So we end up with a ratio of 2 to 3. So Na2S2O3. And finally, 2 steps for this one. First, we need to find the empirical formula using our previous steps. We end up with P2O3 as our empirical formula. The molecular mass, or the MR, is 220. So first we'll find the MR of the empirical formula, so of P2O3, and we end up with 110. 220 divided by 110 is 2, which tells us that our molecular formula is twice as much as our empirical formula. So multiply P2O3 times 2 to give P4O6. So how did you do? Leave a comment with any topics that you really want me to cover next, and I'll see you next time for our next chemistry tutorial. Bye.